So thanks for having me here. I'm really honored to be in this amazing workshop today. And in fact, about the title, I had none in the beginning, and I thought, like, why not reuse Tim's title? So I did that essentially today. Because I don't want to spill too much on what I would like to propose, but in the end, hopefully the title of the imaginary title should be clear. All right, so where are we, and where should we be, and how to get there? So if you look at our technology and applications, it's really one of these prominent examples that you all know. Digital assistants are now everywhere. But if you have tried to work with those, and bring up here this nice example by Barbara Gross, you soon see that you hit their limitations. So for instance, one of these limitations is, in fact, follow-up questions or able to keep the dialogue up. So like we see here, which ends are open. They don't work so well in keeping the discourse up. But what's more, if you look at digital assistants and just take the snapshot of languages or language variants spoken in Europe and look at the three big players in the field, we see that even there is a very low coverage of language variants that are covered today. So this brings me to the motivation, and in fact, let's look at an example here. There is a little 3-year-old Moriama, and she speaks Galician, which is a variant of language in Spain, and she doesn't understand why the tool is not working when she speaks in her own mother tongue. So what I would like to argue or put forward here is that we have this variety in the input, like different kinds of languages or non-standard data, and we typically have a model that we learn to solve some task. But NLP today is not very good to deal with this huge amount of variability in inputs, but also in outputs. And so what we essentially see is that if we have language varieties, they are not recognized, and it means that like minority language or dialect speakers are underserved by current technology. So while our field has really advanced a lot in the recent years, there is this really long tail which we need to work more on, essentially. But even if you had, say, a tool that recognizes your language, then our technology today is typically only recognizing standard categories or majority representations. And so we know that there are these differences in human labels, and we typically do not take them into consideration. So these are these two parts of the coin that I would like to put you forward and make you rethink more about, because I feel often we are stuck with the modeling phase and don't think so much about the input and outputs there that we are dealing with. And in fact, we have seen really big advances by large language models, but if you think about them, they are, first of all, they need a lot of data, and they are also passive learners, right? There is no interaction. You learn them once, and then you just take them. So we cannot easily adapt to variation, language variability. All right, so I think in general what we need, challenges that we need to deal with in the future are to make NLP more inclusive and fair, to support and understand many more language variants, make models also more trustworthy, but on the other side, more efficient with leaner and faster models, but also importantly make them more human-centered, to include human perspectives and better align also with human values in evaluation. And so we talked about generation and heard about generation. And here is an example of a question that I posed to OpenAI's GPT-3. How do I get from Munich to Venice without crossing the Alps? Okay, so if we asked the GPT-3 now, we get this answer. The simplest way to get from Munich to Venice without crossing the Alps is by train. The journey takes around 8 hours, involves taking a train from Munich to Verona Porta Nuova, then a connecting train from Verona to Venice Santa Lucia. You see, we get brilliantly fluent and coherent output, but what about the key missing part of the question, right? The crossing the Alps is completely, even though it spits out this answer, this is completely neglected and not a faithful answer. It also lacks common sense knowledge. Now you might wonder, this is GTP3, but ChatGPT just came out, right? This is kind of an old language model by now. So what about that? Well, I just asked it before here in the room, so today, essentially, this morning. And what happened is this. So probably all of you were busy trying to, no, just kidding. But after a little bit of time has passed, I finally got an answer, and you see here what happens. One way to get to Munich without crossing the Alps is to take the train. So essentially, it kind of gives still the same answer. What's even very interesting here is it also talks about passing the Brenner Pass, but it involves some mountain driving for the train, right? So you see some more weird stuff happening here. All right, so for generation, there's also a lot of challenges out there. Well, we are very good in having AI and robots for like journalism and creating this automatic smaller table or text-to-data output. We really lack good output for longer text, and especially lack of control. We lack factuality and faithfulness, but also creativity, right? And then there is the whole side of social and ethical challenges. I'm not going into any of this here because I'm more on the natural language understanding side, but I think it's important we will hear more about those topics today, I believe. And so if we just step back, how did we come to where we are? Here is a little summary of our field. So we went, you all know this, so it can be fast here. We went from symbolic processing to statistical NLP, essentially where I also grew up with. And then we had this deep learning revolution around 2015 approximately, where it hit our field. And then the next big step was, in fact, contextualized representations and large pre-trained language models that we are dealing with today. So huge advances, and you see that the timeline is actually condensing as we go along as well. And so if we see this as like a dramatic act, you might ask, okay, we have the rise. Is deep learning like the climax? Where are we going next, essentially? Is pre-training a return or fall? And what's the fifth act in this theater play, you might think? So catastrophe or happy end? So, in fact, the question is, are large pre-trained language models all we need? We have heard already previous talks that this is, like also Mark alluded to this, it's not enough. We need to go beyond them, right? I also believe scaling up is not the solution. And here is another view on it, because we have the course of multilinguality. We have models that capture around hundreds of languages, but not much more. And we know that they are not equally represented in these representations. But then we also have the fact that we typically want applications working on different kinds of text domains. And on top of that, we are interested in different tasks. So now that so many more language models are becoming available, how do we even choose one which fits well for a certain task? And so you can think of this as this very huge search space that it's essentially infeasible to look at the whole Cartesian product. So what I believe is very crucial is to learn, in fact, not scale up and train larger and larger language models, because we actually also cannot all do that. But we also need to reinvent and look at how can we learn from scarce data, get a lot of knowledge from little input, and then important questions are coming up like, hey, what about reuse of data, language model, everything we have, and how to deal with breaking this down by taking a modular approach and looking at pieces and how to combine them. All right, so I do believe we need new approaches to deal with this problem. And in the rest of the talk, I will focus on a couple of, some recent studies we have been doing, very small steps in this direction. So I believe we need to go away from big data and learn efficiently from scarce data. And some methods in this direction are to look at incidental supervision, or what I like to call fortuitous data sources. And another idea is, in fact, if you look at what's studied nowadays, here's a nice paper from last year's ACL findings. We have a lot of work in like different dimensions, And you see that they cluster, so it will be also important to go and look at the cross-fertility of, say, multilinguality with fairness and bias and efficiency, not just look at isolated corners, but do more work across different areas. And so in the rest of my talk, I will gonna go into 3 small case studies of works that we have been doing in my lab. And this is, again, all work by my students, so I'm very happy for what they have been doing. All right, now this is work by Max and Rob, and what we were looking at is dependency parsing, so we are still doing parsing, and we were looking at genre information in dependency parsing. And why that? Because universal dependencies is a huge project which has led to a lot of multilingual or cross-lingual NLP. But if you look at what's contained in that tree bank, then we actually do have genre information. So we try to quantify this information in this UD data. And what you can see is there's a lot of news wire data. And there's a long tail of other kind of domains where you see spoken or social or so on are much less frequent. And we typically only look at the cross-lingual dimension. So this is really across all languages and all domains what we have, quantifying the lower and upper bounds. And what's in fact not less known is that the tree bank providers tag their tree banks with this meta information on genre. And if we try to find information about it, and here's a paper by Jochen Iver and colleagues, and they say, this specifies some amount from different genres as reported by each tree bank provider, but these categories are neither mutually exclusive nor based on a homogeneous criteria, but it's currently the best documentation that can be obtained. So the idea is, hey, we want to document somewhat what kind of data is in these tree banks. And that these are the labels that they came up with. So the question is, can we then use this kind of labels to do better data selection? So if you are, say, working on a low-resource language and training or working on syntax, you might want to have a good parser for that low-resource language, for that specific genre. And now, if you go and train on, say, all of the universal dependency tree bank data, really a massively multilingual parser, you know that it's not working very well for your target. And, okay. So if you have some like Varieties lyrics, and you train the model on everything, you know that it's going to be suboptimal. And it also takes a lot of time to do it. But what we wanted to investigate here, can we actually find better suited target training data, so do data selection, in order to train the parser on less but more specific data, more relevant data for the problem at hand. And the problem is that, in UD, so here it's illustrated as if every sentence, every tree knows which kind of genre it belongs to. But the issue is that these labels are just at the tree bank or corpus level, so you need to find ways to propagate them to the instance level. So we proposed several ways to do so in order to then select these, and just as a short conclusion, details are in the paper. What we saw is, first of all, if we take a multilingual model and try to look at these dimensions of variation, we do already see them back to some degree, so the colors in this plot. But if we then propose some methods which uses weak supervision to inject or augment this information, we get much more clearer separation, and that actually helps us to select better training data for this target-specific problem. So we could improve zero-shot dependency parsing for the 12 low-resource languages that we had here. And for instance, for Varieties, we got an improvement from 61 to 68% LES. And I think this is like showing, hey, there is this metadata. Let's use it instead of neglecting it, essentially. And so this is one example of how we can use kind of fortuitous data to learn models from less data. And in the next part, I will show you an example of reuse, essentially. And so this is a paper that comes up here at the NLP. With my PhD students, Elisa, Mike, and Max, we were looking at, hey, there is like large pre-trained language models coming out at a really fast pace. base. And now if I asked him what language model to choose, he might come up with some answer, right? But it's often really, really based on heuristics or prior work, but because simply training on all of them is infeasible. So I think one of the interesting directions here is also how can we select a large language model a priori, finding the best encoder for a certain task at hand. And this is the problem of transferability and transfer prediction, essentially, transferability estimation. In NLP, that hasn't been done so much so far. There is work on a related problem, namely performance prediction. But here we were interested in, given a set of pre-trained language models and some target data set, how can you estimate a score that then correlates well if you were then to fine-tune the model on. And we took a framework that comes from the computer vision field, so LogMe, and essentially just applied it to NLP problems to see how good it performs. We tested this across 10 tasks, 4 setups, and 7 large pre-trained language models, where we included general ones, but also more target domain-specific ones. And again, a shortcut to the results. So here you see all of the tasks that we tested it on. We had classification tasks. Oops. We had the blue ones are classification tasks, and these ones are sequence labeling tasks. And what you see overall, if you take the frozen, we don't fine-tune the representation itself. There is quite a good correlation with the final fine-tuning performance. So this is what you're trying to predict from the score that you get. And there is a good correlation across the field where, you know, the LogMe framework is able to identify some obvious or some intuitive things like Twitter, the Twitter language model. Twitter Roberts is good for airline Twitter. But it also finds some less intuitive ones, like this Dilbert turned out to be a very good language model for a lot of these sequence labeling tasks. So we were wondering also, hey, how good are humans, or in our case, NLP practitioners, at identifying the best language model from the set of language models that we had here? And we found, it was admittedly a small study, just 12 NLP people, and we found, though, that their correlation was worse than the one found by this method. So take that with a grain of salt, but I think it's interesting to see that we're not always the best oracle to choose from. We have a poster on this on Friday if you're interested in this kind of work. All right, and in the last part, I want to touch up on another kind of problem, and that's human labor variation. And so typically, you know, we all know when we do annotation projects that we observe disagreement in annotation, and but we largely ignore it and just aggregate the data to find a final gold label. So the question is this really a problem, or should we step back and instead of going the route to the typical gold label, look at information from the multiple or unaggregated data? And so one nice example is, in fact, a study by Eli Pavlik and Tom Kwiatkowski. They looked at the NLI data and re-annotated it with 50 annotators. So here is an example of a premise and a hypothesis. Amanda carried the package from home, and Amanda moved. And what they found is when they let people re-annotate it on a scale, then they saw that there is a lot of entailment, but there is also another, you know, not just a unimodal distribution that comes back from this data. So there's, this is an example from NLI, but there is a lot of other work that shows that there is perhaps not a real ground truth. And this is an old idea, so it goes back even by Sissy Alm already pointed it out on subjective task, questioning whether there is really, whether there is an absence of ground truth. For instance, she looked at emotion prediction and so on. And there is now recently an increasing interest in this problem, especially if you think of tasks that are more connected to the human, right? Like offensive language detection, abusive language detection, where it's really, really a very challenging task to get data, and just one ground truth, essentially, meaning one perspective. But there's also work on that outside NLP, or here in visual question answering, but also more in the computer vision area, where they start to look into this problem as well. And I want to mention that I talked so far about disagreement in annotation, but this is not always just disagreement. So I would like to propose the more general term, human label variation, to kind of capture the fact that some of it is disagreement, but there is also different perspectives, and there's even tasks where we might want to have multiple plausible answers. So we can all see this as human label variation, which though is something that we think is genuine. And it is clear that we need to distinguish this from plain noise, so like annotation errors, but the question is how to do this. So this is a very challenging, where to draw the line even between annotation errors and genuine human label variation. And I did this also because there is a huge literature in that, referring to that in different ways, like perspectives, human uncertainty, hard cases, disagreement, and so on and so forth. If we then assume that this is there and we want to use it, so what can we do? Again, there is a large literature in it, and I try to see it into two big camps. One is those who argue that we should resolve it. We should go back to the single ground truth, essentially. Here we might think about aggregating or integrating it into aggregation methods, or take another approach that filters out data, versus embracing this variation. And here we see works that go back to as early as 2008, repeated labeling, and some more recent approaches that use learning directly from soft labels and so on, versus works in NLP especially, where we still assume one ground truth, but use the distribution as kind of a regularizer for your methods for learning. And I will not go into any results here. I just want to mention some related works, which I find very interesting. So there is the work by Data Maps and Swapna, also ACL talk. And she showed that, in fact, if you look at data maps and the kind of instances that, in the end, are in this ambiguous region, essentially, you can learn a classifier on just the ambiguous part, so the gray one here. And in distribution, it performs similarly than training it on all of the data, although you only take 1/3 of the data. So I think this is great. But what is even more striking is if you train on the ambiguous cases, then the out-of-distribution performance jumps up. So that helps to get better generalization performance. And I think this is really related. So we took this idea of data maps as well. So this is Mike. And he looked at, hey, can we essentially distinguish this boundary here from hard to ambiguous cases in order to come up with an acquisition function for active learning? And he proposed cartography active learning for doing so, where we kind of rely on data maps learned from little data. I think this is further evidence that learning from human label variation is interesting, but there is a lot of open challenges. So there is a lot of research which is fragmented in different areas, methods proposed, not tested across the board, so we don't know what's really robust yet. We also lack data sets. Hopefully, if you do your next annotation project, think about releasing also your unaggregated data. There is interesting connections to learning from different amounts of labeled data, and there is a lot of unexplored work. I think there is potential here to go to human-computer interaction and other areas to draw and look on how they pose or work with annotators and so on. But at the same time, there is also evaluation is a big issue because we focus often on easy evaluation, and we need to go beyond because many of the works and methods proposed still then in the end assume that there is a single ground truth. So you learn with multiple annotators, but then evaluate against a single ground truth. Okay, so I think there is a lot of opportunities in this space. Some ways forward, well, we need more data. So please help collect and release more annotated label or unaggregated labels. Here is a data set, a resource that we recently published in order to help people get started with it. But there is also this interesting connection to model uncertainty. And there is a recent study by Davani et al. That shows, in fact, if we compare to this multitask learning approach that they proposed to the original human distribution, it is a better match to the human distribution, in fact, if we try to model this data. Our PhD student Dioris has looked at this agreement from the calibration perspective. So if you're familiar with, you all are familiar with calibration, we know that this is a huge problem in deep neural nets, that they are not very good at not knowing when they, knowing when they shouldn't know, essentially. And so here is a plot where you see that the classifier is very miscalibrated. So ideally, the bars are all on the diagonal, but there is middle confidence, which is here popping out, and otherwise it's underconfident. But if you think about this problem, then calibration still assumes that there exists a single ground truth that you compare to, right? So these bins are based on accuracy. And we examine calibration at the lens of human disagreement. And what we found is that it's actually pretty flawed, or doesn't help us yet very much. So imagine now we use a method to get a better calibrated model, like temperature scaling. We can improve the calibration plot, the reliability diagram, and we can improve the score that is typically used for calibration, like the empirical calibration error, ECHE, here up. But what does it really mean to improve ECHE from 14 down to 3? Right? So this is really hard to interpret. And so what we proposed is to look at the individual instances. And if you have this human annotated data, then we can also investigate how different they are on the instance level. And then what we saw is essentially we can dig deeper into this reliability plot here by looking at the individual instances. And so we saw that overall, here in the lower plots, the model by temperature scaling gets fewer extremely miscalibrated instances, right? So the tail is shorter. But on the other hand, we also see a bump in the beginning. So we also get fewer perfectly calibrated instances. So although we got a huge bump down from ECHE, we might not even want this output, perhaps. So we want to make you think about how we use calibration these days. And for more results and insights, please come to Joris' talks on Sunday. All right, so let me finish almost up here. Not all human variation is noise. I think we need to embrace it more in learning. Also evaluation. I talked a lot about understanding and classification tasks. I think some of this is also important for generation. But we need to identify what are good approaches, and how to evaluate in light of label variation is a big open problem. If you're interested, there is a semi-eval shared task on this running right now, so please consider participating in it as well. And yeah, we'll skip over this here to wrap up. I do believe that we, in general, need to enable more inclusive, reliable, and human-facing technology for language understanding. And I've shown you a little bit of direction I think are important. So learning from scarce data, reuse, and then there's other methods like modularity, embracing human label variation, and something I haven't talked about here, but instead of going for passive learning, we need to go to more active human in the loop regimes, and also cooperation with humans in the long run to make the models do what, to exploit their full potential together, essentially. And with that, I thank you for your attention and look forward to your questions.
Questions? I have all the mics. Zero, come and collect a mic.
Oh, I'm getting one here.
Oh, there are lots of mics.
Right. Yeah. Oh shit, that's close. Hi, Barbara.
Hi. Sarak.
Okay, so you talk about learning from scarce data, and I think you're absolutely right, and that's the direction that we need to go in. But is that possible with the current technologies that we have that rely on salience? What do we do?
That's a good question. No, I don't think we can just run, MLM masking on very little data. We might get some gains, not, but we need better objectives, better incorporation of prior knowledge as well, more structured objectives, I would say. So not just the current technology. It's similar than the long former. You know, it's if you scale up to longer text, it's the same method, but does it help you getting better representations? No, and I think the same is if you downscale, we will not get better representation. We will get for sure worse representation. So we need the other ways to find inductive biases that help us with modeling.
All right. Thanks, Barbara, for the interesting talk. I have a thought or maybe some question for you regarding the human level variations. So yeah, I do agree that human level variation might be perhaps give us some insight about the model. But my concern is, yes, it might be like that if we have annotations based on expert annotators where we believe they equally understand about the process of the annotations. And what if they are like, you know, crowdsourced workers? Did you do some like analysis about the inter-annotator agreements until which point we can say that this variability can be useful for the model? Maybe if the annotations result in kind of like 0.3 kappa score, for instance, it's not useful. I don't know. Have you done something like that?
Yeah. No, I didn't do that myself, but there is work on this, of course, in the annotation aggregation literature. But even though, you know, maybe we need to revise the way we are doing inter-annotator agreement, because we assume that that's also applicable, the same kind of threshold would be applicable to every kind of task the same way, at least this is how we often perceive it. Maybe we don't need exactly those metrics or just one again. We need to look at multiple metrics, multiple things. I do think that also lay people can give a lot of useful information. Even experts make errors, and if you ask the expert again, you might get a different answer. So this is a very complex problem that we need to. So my main point, maybe it didn't come so much true, but I think, you know, annotation disagreement has been studied a lot only on the data side, but impacts the modeling and impacts the evaluation, and we need to take this as a global problem in order to advance. So there is no clear answer for a score threshold, I believe.
Hi, Barbara.
Hey.
Thanks for the talk. So about variation in annotation. At least part of it, most of it comes from the fact the annotators can come from different social demographic backgrounds, right? So for me, it looks like if there's disagreement in annotation, it's because we don't have the full data, right? We don't have the full information about an instance. And so correct me if I'm wrong, but you try to advocate that, oh, we should embrace this variation in our modeling, but wouldn't it be better to instead like try to aim for more personalized systems which actually take into account that social demographic variation? Because in truth, you have one label. It's just that you don't have that in your data, right? So wouldn't that be a better way forward? It's because I think my concern is like, okay, we try to make systems that at least try to behave like humans, but in practice, these systems are not a single, they try to do like a washing out like of an average of all the humans that annotated your data, right? So
right.
Are we doing it? So, okay, so to exaggerate, isn't this wrong, or is there actually a reason why you should keep doing that? And yeah, if you could comment on that.
Yeah, that's a very good point. I do strongly believe, but ultimately we would go into more personalized system and personalized view, especially in these subjective tasks. So it's very connected to that, and there is even work on, you know, the annotator demographics, and connecting Martin Sapp, for instance, has done work in this direction. It's all interconnected. Yeah, you're right. But I do believe for some, it's always again for some tasks that you might want to have more personalization than for other tasks. So in general, I believe there is still value in going to not just go for the mean, essentially, but embrace the variation that you capture. In general, even if you then in the end spit out, you know, don't personalize as well. But I think personalization is a very important motivation for looking at this even more. Yeah, agree.
Thanks.
We've got time for one more question.
So you started the talk with noticing that currently we have to choose from this large search space which language I should focus on, and if I have multilingual models, you have the curse of multilinguality, kind of the start, kind of, you know, not being good for any of those languages and so on, and then which domain and which task, right? So the question is, how do you see the way forward? So for example, one thing, okay, if you leave the multilinguality aside, one kind of direction was to say, look, we are going to have just one language model. This is what GPT-3 is telling us, GPT-2, right? And what we're going to do is, well, we're going to look, let's say, maybe in context learning, we're not going to fine-tune it. And people currently are saying, actually, why don't we fine-tune a prompt? It can be even a continuous prompt. And now I'm not going to change the model. The huge language model is there, just give you a different prompt. Okay, you still kind of need a library of prompts for every single task that you want to do, but kind of, how do you see the solution?
That's a very good point. So I didn't talk about prompting, you saw not much in that direction, because there is a lot of variety in sensitivity to that as well. No, I do think, I don't know, also if you look now with the project, we're looking at dialectal variation and Germanic variants, for instance. You will need to work more. I think we need more work that estimates what's good and tries to find out how to do transfer from not just building one model for everything. I don't think that's the solution. Even GPT-3, if you ask now, do you speak Italian in English? It would say, no, I don't. And if you ask in Italian, it suddenly knows how to, just as a side note. We need more ways to find out when what works in order to even combine smaller models, have more modular approaches, look more at transferability estimation in this space of languages, tasks, domains. Because we often, I still think we need often a target to which we want to adapt to, instead of building the huge cross everything model. So this will be important for applications as well, to find out a priori, okay, to this target, what can I use from all the existing knowledge? In a way, a little bit going back to a pipeline, you might say, pipeline of NLP models that you combine in future, perhaps.
Let's finish up. I'm sure there are lots more questions. Let's thank Barbara again for a wonderful talk.